Welcome, university students, to this crash course. I know exams are right around the corner and the stress levels are probably spiking, but seriously, don't panic. I'm here to be your guide. Today, we're going to break down the massive, complex topic of the Bitcoin blockchain into words so simple you won't need to memorize a single thing. You'll just get it.
Okay, let's dive into this. We're going to cover 1. Bitcoin basics and origins. 2. Wallets and transaction process. 3. Network, mining, and architecture. 4. Security threats and attacks. 5. Advantages and system limitations. And finally, 6. Exam revision and key questions.
Let's kick things off by uncovering the foundations of cryptocurrency in Section 1, Bitcoin Basics and Origins.
So the very first question that always pops up in exams: who exactly is Satoshi Nakamoto? You'd probably think the creator of this massive trillion-dollar network is some famous tech billionaire, right? Well, that's the biggest plot twist. Nobody actually knows Satoshi's true identity. It's just a pseudonym. Could be one brilliant coder, could be a whole team of developers. Who actually wrote that original 2008 white paper? It remains a total mystery. Now, what's really interesting is why Bitcoin was even created in the first place. Back in 2008, the world was hit by a massive financial crisis. People suddenly realized that traditional banks and fiat currency, government-controlled money, had some pretty serious flaws. Banks can fail, funds can be frozen, right? The ultimate solution to this was Bitcoin, a completely decentralized digital currency. No banks, no middlemen, just a peer-to-peer system where the power stays entirely with the users.
Moving right along to the practical application of the technology. Section 2, Wallets and Transaction Process. To actually use Bitcoin, you need two basic things: a Bitcoin wallet and a Bitcoin address. Let's connect this to everyday life. Your Bitcoin wallet is basically just like your traditional bank account. It's the software that holds your balance. And your Bitcoin address? That's exactly like your bank routing number or a payment app ID. It's the unique string of characters you give to someone else when you need them to send you funds. But keep in mind, not all wallets are created equal. You definitely need to know the difference between hot wallets and cold wallets for your exams. A hot wallet is connected to the internet. Think of it like the physical wallet you carry in your pocket every day. Great for quick, daily transactions, but since it's online, it's inherently a bit riskier. A cold wallet, on the other hand, is completely offline, like a specialized USB drive. Consider it a massive, impenetrable bank vault. It's not super convenient for buying a cup of coffee, but for keeping large amounts of crypto absolutely safe, it's the best way to go.
Let's move along and see how this builds in a real-world scenario. Imagine you're sending 1 Bitcoin to a friend. First, you authorize the transaction in your wallet, using your private key, which is basically your unforgeable digital signature. But it doesn't instantly jump to your friend. Instead, it goes into a sort of digital waiting room called the mempool. From there, network computers, which we call nodes, verify the transaction, pack it into a block, and permanently attach it to the blockchain.
All right, put your professor hats on because we are entering the heavy technical architecture. Section 3, Network, Mining, and Architecture. I just mentioned the word nodes, but what actually are they? A Bitcoin node is essentially just a computer connected to the network. Think of this entire network as a massive public ledger or record book. But unlike a traditional bank where only the manager holds the ledger, in the Bitcoin network, every single node holds an exact, perfectly synchronized copy of it. If anyone tries to cheat or fake a transaction, the other nodes simply check their own ledgers and immediately reject the lie.
Let's unpack those blocks for a second. A Bitcoin block is like a secure digital container. Inside, it holds a batch of verified transactions, a timestamp, and a cryptographic link to the block that came right before it, which is literally what forms the chain. Buried inside these transactions are Bitcoin scripts. These are basically simple, automated rules that act like a digital lock and key, ensuring that only the person holding the correct private key can actually spend those specific Bitcoins.
So who actually packs these transactions into the blocks? Enter Bitcoin mining. Now, mining isn't literally digging a hole in the ground, it's a massive digital competition. Think of it like an incredibly complex Sudoku puzzle that requires a staggering amount of computing power to solve. The miner who guesses the correct mathematical answer first wins the right to add the next block, and as a reward for all that hard work, they get newly minted Bitcoin. This whole puzzle-solving process brings us to a concept called proof of work. Listen up because this is an absolutely critical exam topic. Proof of work is the consensus mechanism of the network. It simply means you have to mathematically prove you spent real computational energy and time to find the solution. Because solving this puzzle costs so much in electricity and hardware, cheating the system becomes financially impossible.
That immense computational effort is literally the security shield for the entire network.
Understanding that security is crucial because vulnerabilities do exist, let's look at Section 4, Security Threats and Attacks. And this brilliantly illustrates the ongoing battle to keep the network safe. For your exams, you need to know how to explain these 4 major threats. First up, the 51% attack. This is what happens if a single entity somehow gains control of more than 50% of the network's mining power. If they do that, they can actually rewrite the ledger. Second is double spending, which is exactly what it sounds like, when a malicious user tries to spend the exact same digital coin twice. Third is a Sybil attack, where a hacker creates thousands of fake node identities to surround a user and feed them false information. And finally, selfish mining. This is when a miner successfully finds a block but secretly hides it from the rest of the network to get an unfair head start on solving the next puzzle.
Let's neutrally weigh the pros and cons of the entire system now in Section 5, Advantages and System Limitations. On one hand, the advantages are undeniably revolutionary. Bitcoin's pure decentralization completely removes greedy middlemen. Its security is practically uncrackable, and it gives open financial access to literally anyone with an internet connection. But we cannot ignore the limitations. The network struggles with major scalability issues. It's incredibly slow compared to a centralized system like Visa. Plus, the elephant in the room. Proof-of-work mining consumes a massive amount of electricity, which draws a lot of valid environmental criticism. All right, wake up if you've zoned out. We are at the final and most important part for your academic success. Section 6, Exam Revision and Key Questions. So, the crucial point is, can you mentally answer these classic university exam questions right now? Who is Satoshi Nakamoto, and why was Bitcoin created? Can you clearly explain proof of work? What's the main difference between a hot wallet and a cold wallet? And how exactly does a 51% attack work? I challenge you to recall these answers in your head right now. If you can confidently explain these 4 areas, you are perfectly ready. As we wrap up, I want to leave you with this provocative final thought. Is our current financial system truly ready to be completely replaced by the blockchain? We've seen its brilliant advantages, but we've also seen the undeniable energy limits and speed bottlenecks. Maybe its ultimate destiny isn't to replace traditional banks, but to force them to evolve. Keep that question in mind as you study. Best of luck with your exams, keep exploring, and I'll catch you in the next explainer.